In this video, we will discuss how to find the number of line of symmetry and the smallest angle of rotation that maps a regular polygon onto itself in geometry. Now, what we are going to do, we will discuss what is line of symmetry. A figure in a plane has line of symmetry if the figure can be mapped onto itself by reflection in a line. The line of reflection is the line of symmetry. A figure can have more than one line of symmetry in regular polygons. So we are going to discuss about the line of symmetry. Right now we have a pentagon. Let me change it to uh, a regular equilateral triangle. Now I'm going to discuss about that. Let us talk about in this little triangle, what is line of symmetry. If I The line of symmetry as described here is a line when let me draw a line of symmetry. Yeah, here is the line of symmetry. So this is the line of symmetry in a regular or in a equilateral triangle. Line of symmetry, if I draw a line from one vertex which connects to the midpoint of the opposite side, if I fold this triangle along with this line, then the two parts will be one will be sitting on top of the other one like this. So when I fold it, it sits, the two parts, they are overlapping. So that is how the line of symmetry. So in an equilateral triangle, one line I'm showing here, I can draw another line starting from this vertex point, and I can draw, and which is going to connect the midpoint of the opposite sides. So there will be another line. So now I'm going to discuss the line of symmetry on this triangle. So let us see how many line of symmetry I can draw using this equilateral triangle. You can see that these two red lines of symmetry, they are connecting the midpoint to the opposite vertex. So there are three line of symmetry when we have three sides of a polygon which is equilateral, or it is a regular polygon. So there are three sides. If I fold along with any of the side, the two part of the triangle will be sitting or will be overlapping. So what happens if I have four sides? So let me change this to four sides. Now I can see that there are four sides, and now I'm going to draw in a um, polygon which has even number of sides. We can draw by connecting the opposite vertices. So if I connect this one with this, that will be one line of symmetry. When I can connect this vertex to this one, it is going to be another one. So let me draw it. So these are the line of symmetry you can see, and the other two line of symmetries are coming from the midpoint of the opposite sides by connecting this. So if I fold this um, square, there are going to be four line of symmetries. Now let us try what happens if I go to the next um, polygon, which is pentagon, which has five sides. So here is five sides. So how many line of symmetry I'm going to have when I draw it? You can see the line of symmetries. Now it is five sides. It is like a triangle which has three sides. In this case, I have to draw each line of symmetry from the vertex, and it will connect to the midpoint of the opposite side. Like this line, it is one. Then I will count from here, this vertex, and it goes to the opposite side, that is 2. From here to the opposite side 3, this is 4, and this one is 5. This one we have already counted, so there are 5. So if I have 5 sides, then there are 5 line of symmetries. If I do the 6 sides, so let me increase one more, here you go. So this is 6 sides, and the line of symmetries are going to be in this one 6. The 3 of them will be connecting the opposite vertices, and the other 3 will be connecting by the midpoint of the opposite side. You can see that this vertex, the red line of symmetry, is connecting the opposite vertices. This one is connecting to the opposite vertices, and this one. So there are 3 of these, and the other 3 are by connecting the midpoints of the opposite sides. So there are 6. Likewise, we can draw any of those. Let me do one more, and then we will switch. There are 7 of these, so there are going to be 7 allied line of symmetries, and because 7 is an odd number, so we can count from each vertex. So this one is goes connect to the midpoint of the opposite sides. Likewise, this one comes and connect to the midpoint of the opposite side. So you have 7. So we can have as many number of line of reflections as the number of sides increases. Like this is 8, 9, 10, 11. So all those we can count, and we can find how much is going to be the line of symmetry. Let me go back to uh, a triangle. Like this one is a triangle. Now I'm going to discuss about the angle of rotation or rotational symmetry. A figure in a plane has a rotational symmetry if the figure can be mapped onto itself by a rotation of 180 degree or less, which is very important to understand. 180 degree or less about the center of the figure. The point of the point is called the center of symmetry. The rotation can be either clockwise or counterclockwise. So let us discuss about this, and this is the very important point when they say it can be 180 degree or less. So I'm going to do the rotation, and if I rotate this triangle, when the pink triangle is exactly going to sit on top of the yellow triangle, that is a rotational symmetry. So let us figure it out. It is an equilateral triangle, and let me show the angle of rotation. Right now it is showing 50 degrees. Now if I move this, and so when the triangle sits on top of each other, the angle of rotation is 120 degrees. If I continue moving this angle in the counterclockwise, you will see after reaching to 180 degrees at the most, though it is not the angle of rotation because the two triangles are not sitting on top of each other, then if I continue moving in the same direction, you can see the 180 degree angle arrow is going backward, and it matches again at 120 degrees. So in an equilateral triangle, you saw that the angle of rotation is going to be less than 180, and the angle of rotation is 120, and that is the only angle of rotation or angular symmetry you can have. Likewise, if I have four-sided, so let us do when I have four-sided, so what will happen on the four-side? Four-side, again I'm going to see this is the angle. If I rotate this, so I can see that this pink square is going to sit on top of the yellow square only when the angle of rotation, let me show you the angle of rotation. Here is the angle. Now it is right now it is showing 63 degree, and the two squares are not overlapping. So let me move this, and if I move this, you can see it is moving, and the two squares overlaps when the angle is exactly 90 degrees. Again, if I continue moving the pink square in the counterclockwise direction, you can see when it reaches the two squares again overlap once it reaches to 180 degree. So the smallest angular rotation in case of a quadrilateral or in a square is 90 degree. It also has another angular symmetry which is 180, but the least angular rotation is 90 degree. Let us change to the next one, which is pentagon. When you have pentagon, you can see the angular rotation. We are going to find it. So when angular rotation we are trying to find here, it is not the angular rotation. Let me show you the angular rotation, which is 60 degree, and if I keep moving in the counterclockwise direction, we can see when it reaches to 72 degrees, then that is the angle of rotation, when the rotational symmetry and the angle is 72 degree. If I continue moving this, and so you can see when if I keep it moving, this the next angle of a rotational symmetry I see is going to be 144 degrees. So that means it's again matching. So the smallest was 72 degrees, and then if I continue moving in counterclockwise, I see the angular rotation. The next one I get is 144, but it is never going to be more than 180. You can see the arrow, and once it reaches to 180, and if I continue moving in the same direction, then the arrow goes backward. So the angular rotational symmetry is, in this case, when it is a pentagon, it is going to be 72 degrees, which is the least angular rotation, and the other one is 144 degrees. So that is the two of these. I got it. Likewise, if I change it, six sides, and if I see how much is the angular rotation, and if I click it, we can see it is going to be, let me see the angular rotation, which is 44 degree. So we got it, and if we keep moving, so we can see it is going to be, right now it is 59 degree and it is 60 degree. So the least rotational symmetry is at 60 degree. The next one, you can see it is going to be 120 degrees. Let me make it. And then after this, if I keep moving, the third one is going to be 180. So we see there is a pattern. So that is 180. So there in a six-sided polygon, so we found there are three rotational symmetry. The least one was 60 degree. Then the next one was 120, which is the multiple of the least one. And the third one was 180, which is again the multiple of the least one. So we got these ones. So we can find a pattern or something, even if we have more sided, we can see the angular symmetry is going to be, it will increase. So the maximum, but it has to be less than 180. So let me go back and finish this. So if it is triangle, there is going to be, so let us do, this is the formula, this is the one we can use it. There are three line of symmetries, and because if it is a equilateral triangle, and the angular rotation is going to be 360 divided by 3. Likewise, if I have 4, it is going to be 360 divided by 4, which is 90 degree. I hope you understand the presentation, and you will be able to apply them.